Hi, we're from Qinyue, and our project instructed by Professor Zhang and Riemann is measuring the indication and network effect of the SDGs. SDGs represent Sustainable Development Goals that are developed by United Nations for global or national development um, in areas such as equality, education, poverty, and well-being. And there are like a total of 17 goals. The SDGs are designed as of a hierarchical structure where under each goal there are multiple targets, and under each target there's multiple indicators. And these targets and indicators serve as evaluation matrices of the performance or achievement of the 17 goals. Uh, SDGs are also designed as interconnected with each other, and there has not been much research on how to quantitatively measure the connections of SDGs, particularly at the indicator level. To solve the problem, we built a text-based network model and a coefficient network models of different countries, and in this case, is Indonesia and Guatemala. In addition to looking at the connections, you also want to see if the more generalized text model built from indicator definitions and descriptions will be able to predict any connections reflected in coefficient networks and whether there are some sorts of generalization across different coefficient network models of different countries. Based on the main takeaways, we would suggest that for accuracy purposes, that we build a country by country coefficient network model in future analysis.
So to start, we wanted to introduce a bit about what social network models are and how they're helpful for this particular goal. Social network analysis allows us to understand the structure and dynamics between individual nodes within a community. So applying that to SDG indicators, each indicator can be conceptualized as a node, looking at them in relation to other indicators or other nodes. The relationship itself can be quantified by ties, which is visualized here. And looking at these different structures of the community of indicators, we can see also different patterns, for example, which indicators tend to all cluster together, and also which indicators tend to have interrelationships with several other indicators versus which indicators only seem to have relationships and correlations with a few different indicators. So for an example of how to apply this type of model to SDGs, we can start with a question. What do we think happens in Indonesia when forest area would increase? So in this case, with a social network model, we can see that forest area increasing in Indonesia tends to correspond with increasing renewable energy, but also with a higher prevalence of malnutrition. While these relationships are not necessarily causal, this type of information would be really good to explore more and more like very interesting to decision makers when they're thinking about which indicators to be investing in, like for example, in this case, investing in improving forest areas in Indonesia. So how do we build these social network models? Between the three different models that we are primarily focused on, the most difference between the text models and the two coefficient models is basically based on the data and what we quantify as being an interconnection or a tie. For text models, we're using textual data and taking the principle that if two indicators sound similar, they're more closely interrelated. So as you can see from the example, when the text, like the keywords look similar or like something in the textual definition of these indicators look similar, they're shown as having a relationship. And we use TF-IDF and cosine similarity to quantify these ties. For coefficient models, we're looking at national level indicators yearly index as data. And our idea is that if two indicators change similarly or inversely over time, they're more closely interrelated or shown as having a tie. As ties here, we can look at year over year changes for each country at the indicator level. And primarily the challenges that we addressed in this project are as slightly introduced in the beginning. Our first challenge is mostly the unprecedented nature and sparsity of previous literature. So we're trying to make sure that our building of these models and the scoping and methodology are very defensible and accurately model relationships between goals at the indicator level. Challenge two, after building these models, is that we have to find interpretable and interesting linkages in network models. And finally, we wanted to look at generalizability between the text models and between the coefficient models, as well as looking at the generalizability of the coefficient models between national contexts.
To illustrate one of the findings, we can see that
the text model is dissimilar to the coefficient model. Here, let's focus on the shape and subgrouping of the network. Everything is somewhat connected with many subgroups, and biodiversity as a thing seems to be an individual cluster in the text model. However, in practice, in our coefficient model, we could see now indicators are split into distinct subgroups. And we can see that biodiversity is not an individual theme in any of the subgroup, but now looks like it's pervasive throughout two distinct clusters. As for the potential benefits of the project, most importantly, it provided a network perspective of looking at the SDG indicators, and it could also be used as a tool to a large range of potential users. Thank you very much.